session, I am going to experiment O2 compression test on concrete cube. AIM to perform compression test on concrete cube by using universal testing machine. Apparatus: a UEM or a compression testing machine. Cube or cylindrical shaped specimen of concrete, vernier caliper and linear scale. Reference: Indian standard is 516, 1959, and ASTE AMC 39 for cylindrical specimens, with the general procedure involving curing the concrete specimens for a specified time. Theory: the compressive strength of hardened cement concrete is the most important of all the properties. Therefore, it is not surprising that the cement is always tested for its strength at the laboratory before the cement is used in important works. Strength tests are not made on neat cement paste because of difficulties of excessive shrinkage and subsequent cracking of neat cement. The compression test is just opposite to tension test with regard to direction. However, there are certain practical difficulties which may induce error in this test. They are difficulty in applying truly axial load. There is always a tendency of the specimen to bend in addition to contraction. To avoid these errors, usually the specimen for this test shall be short in length, not more than 2 times the diameter, in a compression test. Strain curve is drawn up to the elastic limit of proportionality. Metals have approximately the same modulus of elasticity as in tension test. Compression test is mainly used for testing brittle materials such as cast iron. Concrete, etc. Brittle materials commonly fail along a diagonal plane due to shearing. Several structural components such as columns and struts are subjected to compressive load in applications. These components are made of high compressive strength materials. Not all the materials are strong in compression. Several materials, which are good in tension, are poor in compression. Contrary to this, many materials poor in tension but very strong in compression. Cast iron is one such example. That is why determination of ultimate compressive strength is essential before using a material. This strength is determined by conduct of a compression test. Compression test is just opposite in nature to tensile test. Nature of deformation and fracture is quite different from that in tensile test. Compressive load tends to squeeze the specimen. Brittle materials are generally weak in tension but strong in compression. Hence, this test is normally performed on cast iron, cement, concrete, etc., but ductile materials like aluminum and mild steel, which are strong in tension, are also tested in compression. Specimen. In cylindrical specimen, it is essential to keep h by d less than or equal to 2 to avoid lateral instability due to bucking action. Specimen size, which is equal to h less than or equal to 2d. 1. Dimension of test piece is measured at 3 different places along its height or length to determine the average cross-section area. 2. Ends of the specimen should be plane for that. The ends are tested on a bearing plate. 3. The specimen is placed centrally between the 2 compression plates, such that the center of moving head is vertically above the center of specimen. 4. Load is applied on the specimen by moving the movable head. 5. The load and corresponding contraction are measured at different intervals. 6. Load is applied until the specimen fails.
640.
डेटा टाकलेला आहे टाकलेला 150 त्याचा क्रॉस सेक्शन एरिया
ते
आणि त्याचे अल्टिमेट कॉम्प्रेसिव्ह लोड किती आले 630 आहे 740.8 आहे. त्यानंतर अल्टिमेट कॉम्प्रेसिव्ह स्ट्रेंथ किती आली 20 म्हणजे हा 30चा क्यू असेल M30.
This is the observation table in this dimension of sample is given. Weight of cube, cross-sectional area, ultimate compressive load, and compressive strength. Weight of cube, kilogram. Each cube specimen is weighed before testing. The weight helps confirm the cube's uniformity and density. Heavier cubes generally indicate proper compaction and lesser voids, while lighter ones may have more air gaps or improper mixing. Cross-sectional area, square. This is the loaded face area of the cube on which the compressive load is applied during the test. For a standard cube of 150 millimeters, hull 150 millimeters. Area 150 he 11. 150 hoins, 500 millimeters square. Ultimate compressive load, kilonewton. This is the maximum load at which the cube fails or cracks under compression in the testing machine. It represents the load-bearing capacity of the cube specimen. Compressive strength, Newton per mm square. It is the ultimate strength the concrete cube can withstand per unit area. This table helps determine the quality and strength of concrete used. The average compressive strength from multiple cubes is taken as the final value for that batch of concrete. Precautions. The specimen should be prepared in proper dimensions. The specimen should be properly to get between the compression plates. Reading should be taken carefully. After failed specimen, stop to machine. Result: the compressive strength of given specimens HD2R 28.9292 Newton per AJ square.